Let's take a look at example 10. It says cosine squared theta plus 3 cosine theta minus 1 equals 0. And our theta is restricted on the domain from 0 to 2 pi. Okay, so this is a quadratic equation. How do you identify a quadratic equation? Well, we have our variable that's squared. Then we also have our variable that's not squared, doesn't have any power, or you could say has a power of 1. So it has a power of 2, power of 1, and then a free term. That's a quadratic equation. It could have more than one free term. It could have another number on this side, like it could equal 5, for example, but you could always combine those terms to make it 1. So not 1, but a single term is what I mean. So yeah, this, you have to recognize that this is a quadratic form. Okay, so in order for it, I could keep cosine. I could keep working with a cosine, but I think visually is going to be easier if for a lot of you, if I make a u sub. Okay, so I'm going to call cosine theta, I'm going to call it a u. So if cosine theta is u, then cosine squared theta is going to be u squared, right? And now I'm going to substitute. So cosine squared theta is u squared plus 3. Cosine theta is just u minus 1 equals 0. Now it's kind of obvious that this is a quadratic equation. And we have different methods for solving quadratic equations. We can try and solve it by factoring, but I believe that factoring is not going to work here. So I'm going to go ahead and apply our quadratic formula. So u is the opposite of b, so -3 plus or minus square root of b squared minus 4 times a times c all over 2a. So that's the formula, quadratic formula. So when we are done calculating everything, that's what we're going to get. And that boils down to -3 plus or minus square root of 13 over 2. So we have two solutions incorporated here. We will get one solution when we use the plus sign, and we get another solution when we get a minus sign. So let's go ahead. So u1 is -3 plus root of 13 divided by 2. When we put this into a calculator, we get approximately 0.30278. All right. Or let's get the second value, -3 minus the root of 13 over 2. And when we put this into the calculator, we're going to get about -3.30278. So now when we got values for u, we're going to now recall that u is actually a cosine theta. So we're going to substitute our cosine theta back in instead of u. And we're going to have cosine theta. The first one is approximately 0.30278. So in order to find theta, we need to do the inverse cosine. Right, which will give us So it's going to give us approximately 1.26319. Okay. What about this side? Let's see. So again, I recalling that U is cosine theta. We're gonna get it's up. Well, cosine theta, it says equals negative 3.30278, but our cosine has the range between -1 and 1, so it cannot be equal to -3 or even more than that. I mean, less than that. So this solution is disqualified, actually. Disqualified because of the range of the cosine. -3.3 is not in the range of the cosine. Okay, so let's go back to our first solution. So is that all? Well, again, just like with the previous ones, the cosine only gives you the value. Our cosine only gives you the values in the top part of the unit circle, right? From and the cosine is 0.3, so it's about here. Like if this is x, 0.3 is probably, I don't know, like here. So that's your angle. Do we have another angle? Yeah, we have another angle here. So theta 1 is here. Now theta 2 is going to be 2 pi minus 1.26319. And that will give me approximately 5.02. All right, so we have two solutions. We have 0.30278 and 5.0200. All right, so now go ahead and practice what you learned. So our next problem that I want you to try is 2 sine squared theta minus 5 sine theta plus 3 equals 0. Again, this is a quadratic in type. So go ahead and try it. And our next example is example 11. This is the last one in this video. And it's pretty easy. The reason I chose it is because this equation has a term that's squared, right? Unknown is squared, and a term where unknown is to the first power, but it doesn't have a free term except like has 0. So there might be, I just want to prevent a mistake. So we're gonna say that sine theta equals some variable, let's call it x, and substitute. What are we gonna have? We're gonna have 2 x squared, right? Sine squared theta is gonna be x squared plus x equals 0. So what I see people do here sometimes, they're going to say, they're going to bring x to the other side, 2x squared equals negative x, divide x out, and they're going to get 2x equals negative 0, so which is 0, and then just solve for x. Now, this is a wrong way of doing it. Don't do it, because the way we solve these types of problems, we're solving them by factoring. Instead of dividing x out, we're going to factor x out. So we're going to have x on the outside, and then inside we have 2x plus 1 equals 0. And that will give us two equations. One equation, x equals 0, or 2x plus 1 equals 0, which if you were doing it this way, you would totally lose this solution. You got x equals 0 solution, but you totally lost the second solution. So it's just a warning not to get too excited too fast. So this is going to be 2x equals -1, x equals -1/2. And then you're substituting your sine theta back in. So you're going to have sine theta equals 0, or sine theta equals -1/2, which are now our basic trig equations that I believe you can solve by yourself. I just wanted you to show this portion so that you don't make that mistake. And for those of you who want to see the answers, here they are. From this equation, you get theta equals 0 or pi. And from this equation, you'll get 11 pi over 6 or 7 pi over 6.